If I have trinomial denominators, same process, just need to factor. So when I take a look here, can't factor this down, but this can be factored. So that's where I'm going to start. 2 over x plus 1 minus bracket x minus 1 to make sure I expand it out properly over, when I factor this down, I'm going to wind up with x plus 1 and x minus 3. And we can see that we have a common factor here. Great. I'm going to look for what's not the same, x minus 3, and I need to add it in to this side. So I'm going to say that I have 2x minus 3 minus x minus 1 all over x plus 1, x minus 3. This is going to give me 2x minus 6 minus x plus 1 over x plus 1, x minus 3. Or, when I combine my like terms, x minus 5 over x plus 1, x minus 3. And this is true so long as x cannot equal -1 or 3. When I look at example B, I got to factor down both my denominators. And as we've seen so far, and it's not always going to be the case, but it's always possible, we're likely to have a common factor when we factor them down. So I'm going to start by factoring and say that I have 1 over y minus 1 and y minus 2 plus 3 over, when I factor this down, y minus 1 and y plus 2. This is all going to be equivalent to, when I look for what's the same and what's different, I'm missing a y minus 2 from this side, so I got to multiply it in. And I'm missing a y plus 2 from this side, so I'm going to multiply it in. So I have 1 y plus 2 plus 3 y minus 2's over all the different factors, y minus 1, y minus 2, and y plus 2. This is going to give me y plus 2 plus 3y minus 6 over y minus 1, y minus 2, and y plus 2. I'm going to combine my like terms and get 4y minus 4. I can factor down that numerator to get 4y minus 1 over y minus 1, y minus 2, y plus 2. And I can cancel out a common factor of y minus 1 from the top and the bottom. This is going to give me 4 over y minus 2, y plus 2, and it's true so long as y cannot equal +1 or positive or negative 2. When I get to example 5, I'm going to start by seeing the simplified form of all of these. Now, some people say, why simplify it when you're just going to expand out the numerators again? And we'll see in just a second. We simplify it to double check if we can't make our lives easier right from the get-go. When I factor down the numerator of the first term, I get x minus 1 and x minus 2. In the denominator, I get x minus 1 and x minus 4. And conveniently enough, before I even start looking for a common denominator, I can simplify. When I take the second one, it's going to be x plus 4 times x plus 6 divided by x plus 2 times x plus 6, and lo and behold, I can simplify. Now, the only thing you have to be careful of with this is remember that because these existed in the beginning, I still need to account for all of these when I'm stating my restrictions at the end. But I can cancel them out to make my life easier right now. So this is now x minus 2 over x minus 4 minus x plus 4 over x plus 2. I can see that the denominators aren't the same, which means that I need to multiply the x minus 4 up here and here, and I need to multiply the x plus 2 here and here. So this is going to give me x minus 2 times x plus 2 minus x plus 4 and x minus 4, all divided by x minus 4 and x plus 2. This is the same as x squared minus 4 minus x squared minus 16. Don't forget to put it in brackets because remember, when we have this minus here, it needs to get distributed out into both those terms. So be really careful with that minus. Over x minus 4 times x plus 2. This is going to give me x squared minus 4 minus x squared plus 16 over x minus 4 and x plus 2. And when I combine the like terms, I'm just left with 12 over x minus 4 and x plus 2. And this is true so long as x cannot equal, and don't forget, we got to look back up here at all of them that originally existed before we canceled out. It can't equal 1, 4, -2, or -6. If I had 4 different factors in the denominator, I have 4 different non-permissible values. All right, last but not least, it wants us to show that this expression can be reduced down to this expression. So let's do it. The first thing, we can see this is in the wrong order right away. Let's fix that. So what did we say? We said that in order to change the order of a subtraction, we need to flip the order and move a negative to the outside. But it doesn't matter where a negative goes on a fraction. It can go in the numerator, it can go in the denominator, or it can go beside the fraction. So I'm going to change the sign on the outside to make my life as simple as possible. I'm going to move the negative up here and say that it's going to be a squared minus 9. Because I don't really want to have to deal with the negatives in my denominator. Then, next I'm going to factor. And when I factor this, I get 2a plus 7 over the factored form of the first one is going to give me a plus 3 and a plus 4 minus 2a over, this is just a difference of squares, a plus 3, a minus 3. And I can see that I have a common factor here and here. So all I need to deal with is my missing factor here and my missing factor here. So I can say that this is equivalent to 2a plus 7 times a minus 3 minus 2a times a plus 4. And it's over all those different factors, a plus 3, a plus 4, a minus 3. I'm going to expand this out, and I'm going to get 2a squared plus a minus 21, and I'm subtracting from that 2a squared, and I'm subtracting 8a. All over the same denominator, a plus 3, a plus 4, a minus 3. Combine my like terms, and I get negative 7a minus 21 over a plus 3, a plus 4, a minus 3. I'm going to factor down the numerator. And get negative 7 a plus 3 and I can cancel out the common factor in the numerator and denominator, the a plus 3, and I'm left with negative 7 over a plus 4, a minus 3. And I get the same answer. All right, go ahead, try some practice.